Hi guys, can you believe it? Week 7, so nearly 8-9 weeks since we've been together in the classroom or in the lab. But anyway, we'll keep going. What else can we do? And hopefully we'll be back together down in Mill Road very soon. So we're going to keep going. I'll go back to the OneNote and just show you where we are. So remember, no homework this week. You have that big task to do based on your element, on your metal. But we're going to start something new. But your only activity or your only submission that I need from you this week, going towards your summer exam, is that little assignment I gave you on metals. And I'll show you that again before we start, okay? So if we go back here, and back to February 22nd, which was last week. Remember this task, okay? So this is your only task that I need from you this week. Maybe I put it down so I can write it. So it's your only task that we need. So and I went through this in the live lesson last week. So if you could submit that during the week, that would be perfect. And remember, that is 8% of your summer grade. So you should get that in at some stage before the end of this week. So you have loads of time. It's only about an hour and a half worth of work. I don't need it until the end of the week. But for now, right, for today, we're just going to go on. And there'll be no homework assigned with this, but it is something slightly different, but in the same sentence. It's the same thing, kind of. It's based around the periodic table, and it's called elements, compounds, and mixtures. So if you think, well, this is a new topic. Well, it is, kind of, but elements are the things that were in the periodic table. Remember, it's called the periodic table of the elements. But it's just that if you think of the elements, hydrogen, helium, lithium, beryllium, boron, well, they're elements, and they're by themselves, they can't be broken down into anything simpler. And these new things we're adding on, compounds, are when elements come together to form something different. And things like mixtures, so you get one element and another one, and you mix them together and you form a mixture. Okay, this video here you should have a look at. It's in the OneNote and there's a link to it there. It's just Daniel Radcliffe, and he is going through the elements of the periodic table. So he's basically saying all the elements of the periodic table in a row. Quite entertaining, worth a look. Any Harry Potter fans will enjoy that video, so I pasted that in there for you. So you can, if you go into the OneNote and hit the link, it'll bring you to Daniel Radcliffe. I think he's on the Graham Norton show in that video. So what we're going to be doing between now and Thursday. So we'll do half now and half Thursday to get through this particular learning outcome. So we're going to find out, well, what's an element, what's a compound, and what's a mixture. That's always the way you start, isn't it? You start with the definition. What are they for? What are they? What's the difference between them? And these things, you remember these from solids, liquids, and gases? You had things like melting. Remember, ice went to water. That was melting, wasn't it? You had condensation, water going to things like gas going back to water. So when you're in your car and the windows fog up, boiling, evaporation, and diffusion. And we've gone through all those already. We're going to find out what's the difference between compounds and mixtures. What's the first 20 elements? We did those already, didn't we, really? You know, we went through all the first 20 elements and we even drew most of them as atoms. We're going to look at this rule, at this law here, the law of conservation of mass. And this, sadly, and to be honest with you, it pains me to have to do this topic over a video or even over a live lesson, because most of this I like to show people as experiments. So and you'll see why as we go through the lesson. But we can get most of the theory done now, and then we'll have all the nice experiments to do when we get back into our brand new lab. Okay, first off, definition. One you got to learn. An element, and one we did learn before. An element is a substance that cannot be broken up into simpler substances by chemical means. So if I have any element in the periodic table, hydrogen, helium, lithium, beryllium, boron, carbon, I can't break that down into anything simpler. If I get carbon, I can't break it down into anything smaller than carbon. Okay, that's the definition of an element. This guy here, Robert Boyle, he's generally considered to be the man who invented chemistry. And he came up with that definition. So if the definition of element is a substance that cannot be broken down to simpler substances by chemical means, Robert Boyle came up with that. And he's Irish. He was born in Lismore in Waterford. So Robert Boyle came up with that definition of an element. The other one, and this is again, we're ticking off boxes off the learning outcomes. A compound is something that's made of two or more different elements combined together chemically. Okay, so if you think of water, most of you'll know this. The chemical symbol for water is H2O. H2O is an oxygen connected to two hydrogens. So here's one element here, and these are a different element, and because they're joined together, we can say that water is a compound. So definition, two or more different elements combined together chemically. Okay. A couple of examples. The one we just drew there was water. Other one, methane gas. So the gas that comes out of the taps, and those little yellow taps that you turn and the gas comes out. Carbon dioxide, you hear about this. Greta Thunberg just began about this. Carbon dioxide gas. And glucose, reducing sugar. Remember I got you to put Benedict solution in the test tubes with the Lucozade or the 7-Up, and you heated it up and it turned red. That's glucose. So that's a mixture of carbon, hydrogen, and oxygen. These are three of them there. Okay. Now, if we wanted to make a compound, again, this is one that I would get you to do. So what I would do, I would give you a little tray of sulfur, which is a yellowy powder, kind of smells like rotten eggs. And I'd give you a little tray of iron. It says iron filing, so it's like iron that's been grated down into a pile of iron. And you can imagine if you mix those together and you ran a magnet across the top, what would the magnet do? It'd attract the iron, wouldn't it? And then you'd be left with just sulfur because all the iron would be stuck to the magnet. But if I heat them up and melt them together, you get this big messy looking yolk here called iron sulfide. And that's a different thing altogether. So this is an element, and when you mix them together using heat, you get this. That's not. What you have over here is a compound. So basically that thing of making a compound is called a chemical reaction. And what's after happening there is after making something new, after making a new substance. So here's our new substance is iron sulfide. We had iron, we had sulfur, and we made iron sulfide. And iron sulfide is the compound. Okay? And this basically just explains what I just said there. If we heat sulfur with iron, it forms iron sulfide. And that's a chemical reaction because something new has been formed. And down here, you have Fe is the chemical symbol for iron, S is the chemical symbol for sulfur, and FeS is the chemical symbol for iron sulfide. Okay? This is the second one I want you to learn. The law of conservation of mass. Okay? So when a chemical reaction occurs, the total mass of what you have at the start, the reactants, is always the same as the product. So what that means is, we have a look here, that if I say to you, right, I want you to take out 6 grams of iron, and I want you to take out 2 grams of sulfur, and I want you to heat them to make iron sulfide, and weigh it then when you get to the end, you'll get 8 grams of iron sulfide. So basically it's just 6 plus 2 is 8. That's what the law of conservation of mass is. Okay, and I'm going through this quite quickly, but you can always pause and go back and listen again if needs be. So this is the same experiment there. If we have, again, iron and sulfur gives you iron sulfide when you heat them. Iron is a metal, sulfur is not a metal, and iron sulfide is not a metal. It's kind of a sticky, squidgy, kind of spongy feeling type stuff. And you like it to see. It kind of actually smells like caramel. Iron is kind of a grey, blacky colour. Sulfur is bright yellow, like the yolk of an egg. And the product is a burnt rasher look. So that's what it looks like when you do it. But again, I'm asking you to try and remember this now, but it's much easier if you could actually in the lab and you could see it, and you will see it. Okay? Right, moving on to a particular element, one that we know, oxygen. Oxygen has no smell, it has no odour. You can compress it like you would in a car tyre or a balloon. And if you want to light a fire, it's not possible. If I light a candle in the house and if I cover it with my hand, the fire will go out. So you need oxygen for a fire. Same as this stuff here. So if you think of oxygen as the first one, hydrogen is the second one. Hydrogen is no smell. Again, I could put it in a car tyre or a bike tyre if I wanted to. And it's explosive. So I'll show you this. I'll show you hydrogen. We'll make a bit of hydrogen and I'll show you how it's explosive. It burns with a loud bang. It's like a banger, like a black cat. Whereas if I mix oxygen and hydrogen together, it's different. So oxygen and hydrogen are explosive or start fires. But when you make something like H2O, here's your hydrogen, here's your oxygen. When you put them together in a compound, they actually put out fires as opposed to oxygen actually starting a fire. They're a liquid, which obviously this is a gas, this is a gas, and this is a gas. But the water itself is a liquid. Water is drinkable, but obviously you can't drink a gas. And you can't compress water. As you know, all liquids you can't compress. Okay, moving on then. Let's go on to mixtures. Now mixtures, so compounds, you have to do something chemical to make them. Mixtures are slightly different. Mixtures are two or more substances just mingled together, but they're not actually chemically combined. An example, if I had the iron and the sulfur in a pot, you see this guy here now, what he's doing is he has iron and sulfur in a pot, and what's after happening is the iron is stuck to the magnet and a sulfur is left on a plate. So he hasn't done the heating thing to make it into iron sulfide, so he just has a mixture. So we need some sort of energy if you want to make a compound, but a mixture is just thrown in. Same as sand and salt, that'd be a mixture. Or salt and water, that'd be a bit of a mixture. But, so they're not chemically combined. That's the difference in a mixture and a compound. Here, and here's a table that shows you the difference. Okay, so a mixture is a single, or compound is a single substance. A mixture is two or more. To make a compound, you need generally heat, some form of energy. Whereas a mixture, we can just toss them in the same, so no energy required. A compound is very difficult to undo. If I have something like that there, how would I turn it back into this and this? I couldn't, could I? Whereas if I have something like here, it's quite simple. I chuck a magnet in and it will take the iron away from the sulfur from me. So mixtures are much more easily separated than compounds. The last one, the properties of the reactant differ to that of the compound. Okay, so that sounds really complicated, but it's not. We went through hydrogen. Hydrogen is odorless. It's explosive. Oxygen is odorless, and oxygen is required to light a fire, as opposed to water, which puts out fires, and it's a liquid and drinkable. So that's what I mean by that. So we went through examples of that. In a mixture, the properties are very similar to the substances in the mixture. Okay. The last bit of this, I'll put it up there for you. And I know that's an awful lot going through. But this goes through different, I think this is a mad sciencey things that you do in the lab, chemical reaction, compounds, mixtures and all sorts of stuff. But there's a little video there for you to have a look at. And it's Crash Course Chemistry, and it goes through the simple chemical reactions that you could carry out, or you do carry out in your kitchen on a daily basis. So worth a look, only a couple of minutes, and you should watch that during today's lesson. Okay, so as I said, I want you to watch those videos. I want you to go through the notes, have a look at all those different definitions and the idea of what's a compound, what's a mixture, a couple of examples, but most of the point, thinking towards summer exams, I want you to make sure that you get this task done and uploaded this week. As I said, about an hour and a half. I gave it last week, and I want it done and uploaded by the end of this week, as I'm given 8% of the summer grade towards, and there'll be another project coming towards the end of next week that will give me another 8%. So I'm building up to try and get it close to 40% by May that I can give for project work, and then the rest will go towards the summative exam, because I like to make sure that people who are not good at exams, get their marks for their project work, and people who are better at the exams also have a chance to shine. So make sure you get that done. Any questions in the meantime, you can send me an email. And if not, I will see you at our live lesson later in the week. Right, thanks, mind yourselves, and I'll chat to you later on. Bye-bye.